Alex. All right, and I guess let's start the stream.
Ooh, go live.
I might have to refresh this thing. All right, hi everyone. We are now live. If you're watching online, feel free to pop a hi in the chat. We have a sizable audience in person, but we also appreciate all of you who are online. I just need to fix a little bit of a setting here to reload. That's for the people who are online, but hopefully all of you in person should be able to see the screen. So, hi everyone, welcome to the 2024 Seattle Infinity Math Circle Summer Camps panel. We have here our wonderful lineup of panelists who will share with you all their summer camp experiences. Most of our panelists are from the Seattle Infinity Math Circle leadership team, but we also have two special guests today who will introduce themselves. And here's today's schedule. Okay, I should probably also advance to the next slide on the for the online people. Okay, great. So we're going to start with panelist introductions. We're going to go down the line. We're going to say our names and what school and year we're from, as well as what camp we went to. Then everyone's going to do a 5-minute pitch for their camp, and there's going to be a corresponding slide for every camp. Afterwards, if you have questions about the specific camp, feel free to raise your hand and answer a question. But at the very end, we'll also do an open Q&A if you have questions for everyone. So I guess let's go down the line and say our names and what camp we went to. So hi, my name is William. I'm a senior at Lakeside School, and I went to math camp in 2022.
So hi, my name is also William. I am currently a senior at Bellevue High School, so graduating this year, and I went to math camp in 2022 and 2023.
Hi, I'm Rohan. I'm a junior at Lakeside School, and I went to QSIS, which is a quantum program, over this past summer, 2023.
Hello, I'm a junior from Henry M. Jackson High School, and I went to Mathly 2022 and Promise 2023.
Hi, I'm Owen. I'm a sophomore at Lakeside, and I went to the Hampshire College Summer Studies in Mathematics, or HCSSIM, in 2023.
Hi, my name is Rena. I am a senior at Skyline High School, and I went to SUMAC, or Stanford Math Camp, in 2023.
Hi, I'm Alex. I'm a senior at Lakeside School. I went to MOP 2020 to 2023, and I went to math camp in 2022.
Hello, my name is Matt Hinton. I am not a student. I am the campus director for the Art of Problem Solving Academy in Bellevue. Thanks for having me today.
I do want to thank Redmond Library for hosting us today, as well as Art of Problem Solving for being our generous sponsor. So I guess we'll start with math camp. Okay, hang on. This is not cooperating. There we go. And let me just change the slide for the people who are online. Oh, and I guess for our panelists, if you can hold the mic, I guess not too close because it tends to cut a little bit, that'd be great. And also switch your slide when the computer gets to you. Thanks. Okay, so I guess we're going to start with math camp. So I'm going to talk for a bit, and then other William is going to talk for a bit. Canada USA Math Camp is a summer program for students 13 plus. The location varies. Last year it was at what was it? It was at Champlain. Yeah, Champlain College in Burlington, Vermont. When I went there, it was in Colby College in Maine, and it's essentially 120 students living together for 5 weeks, learning about a variety of math topics taught by, I guess, like grad students, but also mathematicians from all over. The topics vary widely, so there's a lot of different kinds of content you'll get to experience at math camp. Some of my favorite things were the schedule board. So the campus life is very, I guess, pronounced at math camp. Students can propose any kinds of events they want at any time, and they put up a piece of paper on the schedule board. So here's an example of karaoke night. That was one event in 2022. And yeah, any students can propose any kinds of events. They put their paper on the schedule board saying when it is, where it is, and I really enjoyed the student sort of led nature of it.
So math camp, I guess adding on to that, math camp is definitely a lot about the math itself, but also one really important aspect of math camp is the social part. You get to know a lot of students who are also really, really interested in math. And I think that was one of my favorite parts about math camp was just the math camp community, because every single person there was just so genuinely enthusiastic about math, and they were all excited to go to every single class. So yeah, 120 students. I think every year they enroll about 65 returning students and 55 new students, if I remember correctly. So there's a good mix of people who have experienced the math camp community before and students who have not. And I guess I can talk a little bit about the format of how a typical day looks at math camp. So in the morning, you go to, I think, two classes, three classes? I don't quite remember. Two or three classes before lunch. And then you go to lunch, and then you take two or three, I think one or two more classes after lunch. And then after that, the day is a little bit more unstructured. You have what's called TAU time right after classes, which stands for Time Academic Unscheduled. And essentially this is a period of time in which students can work on homework or problem sets from the classes in collaborative groups. And you can ask for help from what's called the mentors, so the teachers in the classes, and just do the math that's related to the class. Then after TAU, which I think lasts 2 hours until 4, you have what's called colloquium, which is an hour-long talk. It's just a random talk on some random math topic that you have at the camp. It can be a mentor at the math camp, or it can be an invited speaker who is not traditionally a teacher at math camp. And then beyond that, the day is entirely free. So you can continue to work on your problem sets afterwards. You can explore whatever you explore other topics if you want. And yeah, I guess adding on to that, the number one thing that math camp always emphasizes is that you choose your own adventure at math camp. You can decide whether you want to go to this class or not go to this class. You can leave a class block free if you want. In theory, you could go to 0 classes, but nobody does that because why would you? And yeah, everything is extremely flexible.
Yeah, so, okay, next slide, thanks. So here we have, okay, I don't know if you can see that very well, but this is the schedule from 2022 Math Camp. I just had this PDF lying around. I don't know if you can see it very well, but there's a number of classes. Basically, there's only 4 weeks that are planned out at the beginning. The 5th week is left free, and the classes are determined before week 5, but there's 4 classes. You can see there's 4 different class blocks. And one of my favorite classes was computability theory, which was week 1. It was about what kinds of functions are computable and what kinds are not. So it was very interesting. I really enjoyed that class. Okay, anything else?
No, I think that's about it.
All right, awesome. Any questions about Math Camp specifically?
And
If not, you can leave it to the end.
We'll have time for questions at the end as well. So.
Let's check the YouTube chat. All right, hi YouTube. We have 32 viewers, 36 viewers. If you have any questions at any time, if you're online, feel free to pop it in the chat. If not, then I guess we will head over to Rohan. Wait. Oh, the order got a little bit stuffed, but that's okay. Sorry, finding the slide. It's a bit slow. Apologies. All right, there we go.
All right, so it seems that I'm here repping the one camp, which admittedly isn't a math camp, but it's actually a physics camp, but don't worry, it's pretty closely related. So it's on quantum mechanics, computing, and cryptography. It's 2 weeks in August, at least it was 2 weeks last year. That does vary. From year to year, it's at the Institute for Quantum Computing in the University of Waterloo in Canada. So it's a bit different from most of the other camps here. And also, you don't need to do a giant problem set and your application. You just need to have an essay plus a letter of recommendation from a teacher. I can see the people here looking at me like I'm crazy, but look, that's how it goes. The structure of the camp, it's very structured as compared to most other camps here. We had lectures or labs or building challenges from 9 to 6 every day with about an hour for lunch from 12 to 1. And honestly, these lectures can take a very wide variety of forms. For example, we had a physicist from MIT who worked on an ultra-cold atoms research over there that ended up winning a Nobel Prize, talking to us one day about the use of ultra-cold atoms in quantum computing. Some of the fun labs we did, we had to build a quantum encryption system ourselves using photons and polarizers. We also investigated the properties of mirrors as they pertain to photon splitting and sort of how that would work in terms of a quantum circuit. In addition, there were a lot of sort of more theoretical aspects of the camp. Quantum circuits were a large part of this, quantum computing, sort of what is quantum computing, what is computable in quantum terms rather than classical computers, and also how can this be used to solve everyday problems. So really, if you want a hands-on approach to a science which involves quite a lot of math, I definitely recommend going here. Also, it is a completely free camp, and they will cover the cost of your travel if you need it. I think most people got the cost of their travel covered, so that's quite nice of them. In addition, the student life is great. I'm still in contact with a lot of the people I met over those 2 weeks, still friends with them. And one Sunday you go and visit Niagara Falls because, you know, it's nearby. Why not? There's some bowling involved. There's evening activities, sometimes after 6. Other times we will sort of hang around, play pool, ping pong, or do the problem sets which are assigned to us. In addition, the food there was top-notch, restaurant-quality food, I cannot lie. There's a picture on the right, and also on the bottom right you can see an example of when we used liquid nitrogen to make ourselves a bit of ice cream during one of the lectures, so that was also quite fun. Yeah, I definitely recommend QSIS for anyone that's interested.
Alright guys, we're back to math now. I'll be talking about Promise. And Promise is another math program similar to like Math Camp. It happens at Boston University. It is 6 weeks from July to August. And it has 80 students, 60 first years and 20 returning students. Unfortunately, it does cost $6,000 and you must grind a terribly long entrance exam. But yeah, so I would say that the emphasis on Promise is like an open-ended exploration. I say this because essentially what a day looks like at Promise is at about like 9 o'clock in the morning, you head down to number theory lecture, which is mandatory. Everyone has to go, even the counselors. You go to the number theory lecture, and for like an hour and 30 minutes, you have to listen to a dude talk about number theory. But then afterwards, you get a P set to do, which you have to grind. I mean, you don't have to grind it, but it's something for you to take home and basically just, not take home, take back to your dorm or like take wherever you want it, take wherever you want to do it, and you just have to, the whole day is just meant for you to work on the problem set. And it really does not have that much structure to it. They don't have like chunks of time for you to work on your piece here and work on your piece there. You basically just go wherever you want. Personally, I enjoy taking the subway and heading down to Boston and just finding like a place in Chinatown to grind on my piece set. Yeah, so the piece set's basically your whole life for that amount of time. And outside the piece set, you'll have for those very ambitious first-year students, you can go to seminars, labs, and, well, yeah, just seminars and labs. Basically, seminars are an extension of the number theory classes that you have at Promise. It's like, it just covers another topic. For example, last year I remember they had abstract algebra, primes and zeta functions, and some other math term that I can't remember. And those seminars, you basically get 3 days a week. You have to show up to an hour-and-a-half lecture, and you'll get problem sets for you to do between those lectures. Something else to do are the labs, which are exploration labs, which is basically meant to get first-year students a feel for math research. What you'll do in these labs are, you'll choose a topic. For example, I chose fractional linear functions, which sounds scary, but it's really not that bad. And you choose a math topic, and even though it's been discovered before, you're just barred from using the internet, and you basically try to discover as much as possible on this topic by doing like numericals, making conjectures, running programs, etc., etc. something else you do at Promise is guest speakers. So all guest speakers slash mini courses, because all the counselors at Promise will be forced to give you a mini course on whatever math concepts they find interesting. So I remember last year there was a mini course on, for example, which shapes can you construct using straight edge and compass? How many? Yeah, I don't really remember all of the main courses, but they're pretty interesting. You guys should go to them if you guys end up going to Promise. And some very famous people will come and give a talk on whatever famous things they've done. For example, every year there's a Ross lecture or Ross talk or something like that, where the most groundbreaking thing that happened this year, the person who did it comes over and gives Promise a talk on that subject. Outside of the math, your life is basically just do whatever you want. Since they don't structure your day other than the mandatory number theory lecture in the morning, so you really can do whatever you want. You can spend your time in your dorm grinding your whole day away on your P-set, or you can just walk around Boston like I did and do your P-set then. Or you could just play League of Legends in your room. But as long as you do the P-set, no one would really care. Yeah, that's all I have to say for Promise.
So I'll be talking about HCSSIM, which is the Hampshire College Summer Studies in Mathematics. And basically, this is really similar to a lot of the other camps in that it's a lot self-guided. But I think the main thing that's different with HSIM is that there's a lot of time that's mandatory math. So there's 4 hours of morning problem session, and in the evening there are 4 hours for the problem set. And so a typical day will look like you wake up, you get breakfast at 7:30, then 8:34 there's morning classes, then for 4 hours, and then you have lunch. The time between lunch and the prime time theorem, which is basically colloquium, I understand from math camp, is all free time. So that's all self-directed. And the prime time theorem, as with some other camps, you have a guest speaker, and they speak for 1 hour about all kinds of math. And we've had researchers that just published their studies talk to us about what they just published and what they haven't even presented yet. We've talked about knot theory, graph theory, all sorts of stuff there. And then we have dinner, and after dinner there's evening problem set. So that's 4 hours that they block out to work on the problem set. And what's nice about this is that although it is 8 hours of math, it feels really less than schoolwork, because you know that this is the time that you need, that you're going to spend on math, and the rest of the time it's self-directed. So you don't feel pressure to find your own time within the day. It's always set. Everybody comes to evening problem session. So there are a few questions you may be wondering, and the first might be why should I go to HCSSIM, right? So I think the way that HSIM teaches its students was really enlightening for me, because what HSIM tries to do is build a structure of math, an understanding of math from the ground up. And the knowledge that you start with, it could almost be zero, and you build up these theorems, right, that you've been taught your whole life, 1, 2, 3, 4. Why does 2 come after 1? And we build, the properties of natural numbers, entire number systems in our workshop. So what you learn there is really up to you. There's a lot of like mini, courses later on in the final 3 weeks, as this is a 6-week program. And in those 3 weeks, as I heard some like other camps also have, the instructors get to come up with their own courses, and usually it's what they've been researching in college or high school, and it's something really interesting that you haven't heard of before. So I went to a class on like Turing machines, which called like Busy Beavers, and Dirac's dot, which was about like a function that's 0 everywhere but at 0. And there were a ton of other really cool courses there. And for the application system, it's slightly different than some of these other camps because they're not looking, they are looking at a problem set. There's an interesting test that you have to fill out, but it's different as in the interesting test is more evaluating the way that you solve these problems, like whether you have creative solutions or well-written ones, rather than actually finding the solution itself. And of course, there are also essays and teacher recommendations. So it was in Amherst, Massachusetts. It was really beautiful, and there's a ton of space on the campus, but it was also pretty rural. So we like stayed pretty close together. Like there weren't like Chinatown trips, but there were Atkins trips where like we went to ice cream in the local farmers market. So that was really fun. So I'll briefly talk about some of these photos. There was a journal basically for the entire camp every week, and in a typical day behind that you can kind of see some beautiful art for the final week's program journal. And on the right side, we hosted a birthday party for one of the members of HSIM, and that was really cool since the whole community got together. We all brought some food. And there's also, we went on hikes on the first week, and the bottom photo, the long one, is our workshop. And in workshop, you get to meet like 16 other people that you get really close with, because you're spending 4 hours every morning for the first 3 weeks with them. So I developed some really close friends from this, and that's a major reason why I would recommend going to HSIM.
Okay, there we go. All right, so I'm going to talk more about SUMAC, which is Stanford University Math Camp, obviously located at Stanford in California. Just some stuff that you'll find on the internet. It is 4 weeks long. There is a residential option, which was the one I was at, as well as a 3-week online option, usually from June to July. And it's 40 students residential, I believe around the same amount online as well. You have to be a sophomore or junior currently to apply. And the application, honestly, isn't that different from a lot of these other math camps, but I will say it is the most college application looking thing you will ever see. You have to essays, teacher recommendation, you have to make an activities list, in addition to a P-set. And then, I guess the math, it's more of a college-style proof-based math course. So there's one option to do abstract algebra and number theory, so just group theory. You do a lot of constructability things. And then course 2 is entirely topology. I was part of course 1, so I probably can't speak as much to course 2, but yeah. And then I guess some stuff that you won't find on the internet, the math of it is, again, pretty similar in structure to a lot of these math camps. You do a lecture in the morning, and then you have P-set work time in the afternoon, in addition to guest lectures on certain days and other activities. And then you do a research project, which I think is pretty unique. So basically, you pick a topic, you're able to read up on it, talk to a lot of people who do research in that area there. So for example, my sort of research group leader was a current Stanford student who was doing research in the coding theory, which was what I was doing. And at the end, you present your research project to your course, and then there's also like puzzles and then guest speakers, which I talked about. I think also with the guest speakers you get a wide variety of different things. There's people obviously like Stanford faculty who will come talk to you about the research, but there's also like we had a couple people come in who were like competitive Rubik's Cubers, and they would teach you how to solve a Rubik's Cube, which I honestly don't know how to do yet, but so that was really cool because we were basically learning about Rubik's Cubes the same day, like earlier in the lecture, and how that applied to group theory. And then, like, I guess the social life is honestly what I will take away most from it. You get field trips. Obviously, again, Stanford is sort of far from San Francisco, so you'll go into the city maybe like once or twice on the weekends. We went to a beach. We went to Chinatown. There will be like also organized events with not only the math camp, but also like Stanford hosts a humanities camp like at the same time. So you get to meet a lot of different people, not only just math kids, but like also humanities kids. Like we had a bunch of field days. We had like a prom thing going. But you do get free time like around the campus as well. And then obviously like board games, we ended up hosting a mosh pit as well, which was that picture down there. And honestly, like the biggest takeaway is the friends I made, and we actually met up in Boston like a couple months ago now. But yeah.
Cool. Okay. I did math camp too, so you guys can also ask me about math camp. But we have William and William here to talk about math camp, so you don't need to ask me about math camp. Okay, so I went to MOP for 4 years. So MOP doesn't have a fancy logo because we don't have a fancy logo. So MOP stands for Math Olympiad Program. It's basically just like it's like actually the only program here that's like specifically for math competitions. So it's basically 50 to 60 top Math Olympiad kids. Math Olympiads is like a specific type of math competition. So what is it? It's just Math Olympiads. It's like the first 3 weeks of June usually. Oh yeah. So it's hosted at CMU in Pittsburgh, and basically there's no application, there's no essay, there's no recommendation. All you need to do is get a sufficiently high score on the USAMO or the USAJMO. Okay, right? Super easy. Okay. Yeah, like you don't need to write anything. So for structure, we're split into 4 color groups: red, green, blue, black. Basically each day there's three-ish. I don't remember exactly how many. 1.5 hour Olympiad classes. Basically, all the classes are mandatory because, like, they're paying for you to be there to take Olympiad classes. So, and then, so it'll usually alternate. Either there'll be 3 or 4 classes, so there's like 2 before lunch, 2 after lunch, or there'll be like 2 classes in the morning, and then you have like a 4.5 hour practice Olympiad. Made from the previous year's IMO shortlist, which is supposed to be secret, so it's like super cool, and like you get to like do secret problems, and okay. And then life is chill. I like don't actually have many pictures of math here, so the bottom left picture is some friends explored this like massive tower in CMU. It's called like the Tower of Wisdom or something. The bottom picture in the middle is like 10 kids playing Codenames. So MOP actually gets to invite all the best Olympiad kids from other countries too. So in this photo we have some people from Italy, some people from Romania, a German, a Korean, and an Israeli, I think. Okay. And then, so that's the bottom middle picture. And then the middle picture is there was a math conference at CMU at the same time, so we visited. And then the top picture is someone can't solve a problem in class, because that always happens. And then, the bottom right picture is like actual math, and then that last picture is like more Codenames. So, MOP is pretty chill. Let's see, am I missing anything? Classes, tests. There's like seminars, like basically similar. Like staff would basically just like give a talk about whatever. So unlike some of these other classes where like these other camps where you have like a class that like extends the whole program, like the classes here I'm talking, like they're just like 1.5 hours, and it's just like 5 or 6 problems, and because it's like Olympiad style, and it's just like one idea in Olympiads, and then so like there'll be like 20 to 30 different classes, maybe like 10 to 15 instructors, like just because each class only happens once and there's like 4 classes a day. So yeah, and then the community is super tight, just like all the other camps, I'm sure. Yeah. Oh, yeah. Oh, Mathly, sure. Yeah, let's do Mathly.
Erica's good.
All right, guys, you get to hear from me again. Okay, so this time I'll be talking about Mathly. I actually went to Mathly 2 years ago, so even though it's late in the list, I went to Mathly first. Mathly is a very eye-opening experience in my opinion. Like, okay, first I'll tell you like the general information. Mathly happens at Bryn Mawr, which is a college in Pennsylvania. It's 5 weeks. I actually don't know what dates. I think it's July to August. And it has about 45 students, and you get in by paying $4,500 and grinding. They have, I would say that Mathly is very similar to HCSSIM. I think a lot of the instructors from Mathly started at HCSSIM, then came over to Mathly. Because Mathly's better. It also has an entrance exam like the interesting test, which is from HCSIM. It's called the EAR, which is the Exam Assessing Readiness Test, or something like that. And the way Mathly is structured is structured around like what they call interactive teaching, which is basically in the morning and in the night you'll have these lectures. But the lectures isn't like you're boring, like sit in this giant hall while you watch this professor that's like standing at the bottom talk. In these lectures, you'll get to in these lectures, basically the goal is that you develop math on your own, or with the rest of your class, through the guidance of your instructor. In this case, like, for example, if you're trying, if the instructor wants you to try to figure out how linear algebra works, they'll start by telling you about like solving systems of equations and such, and maybe they'll ask you how to like represent it in a different way, and you're like, oh, what if we use matrices? And then it just keeps going from there, and they'll ask guiding questions, give you problems and such. So a day at Mathly looks like, in the morning you have these kind of lectures that I told you about. In the afternoon you have like a 3-hour chunk of free time, so during that time you could do whatever. Unfortunately, Mathly is also in a rural area, or it's like suburbs. It's like 30 minutes from UPenn or something, so yeah, you can't go to Chinatown trips either at Mathly. But yeah, so during those 3 hours, you could probably play like Capture the Flag, Space Cats Fight Fascism, which is a board game, or you could sleep in the hammock like me. After that 3-hour time, you have a daily gather, which is pretty similar to the the daily gather is like prime time and like colloquium. It's pretty similar. It's like the instructors will talk about stuff they think that's interesting, and we'll have guest speakers that come around. And in the night, you'll have time to work on a problem set they give you. This problem set won't be that long, and you're only expected to like work on one of the problems during that 3-hour like nighttime session. And yeah, you just solve those problems, and then you share your findings the next day, which will help build up your understanding of some math concept. Yeah, I think that's it for Mathly.
Thank you. They'll update here eventually.
Eventually.
Yeah, oh, there you go.
There we go.
Thank you so much for having me again. This is probably a slightly different take on camps than my fellow panelists have sort of introduced. So at Art of Problem Solving Academy Bellevue, we do run some math programs. They're designed to be a bit more approachable, probably not as difficult as, say, the MOP, or as grindy as some of these problem sets have been. Speaking of which, we haven't done a math problem tonight, so how about I challenge you all to a math problem? Free swag for someone who gives me the right answer. What is the largest power of 10 that is a factor of 500 factorial? Largest power of 10 that is a factor of 500 factorial. Anyways, back to why I'm here tonight. So alongside our academic year programs, AOPS Academy Bellevue provides summer camp enrichment as well. These camps, they span 2 weeks, only 2 weeks, and they meet Monday through Fridays across these 2 weeks for 3 hours a day. Now, in addition to language arts and science, I'm here to talk about the math camps in particular. Our younger problem solvers, they provide, they work on problems that help develop their geometry and their algebra, as well as their number theory and counting. And then some of our older problem solvers, they'll get to work on more advanced topics like graph theory, cryptography, and topology. And then for the contest folks in the crowd here, we do have middle school level contest camp as well as high school contest camp. We regularly draw from those types of competition circles. We regularly talk about topics and problem types in these sorts of contests. And every day there's a contest that y'all get to compete against with each other. There's a lot more information that I can distribute, but I think that'd probably be best with a discussion with either myself or a member of my team over at AOPS Academy Bellevue. But for now, you're welcome to visit our website using the QR code there, or just bellevue.aopsacademy.org, or send us an email at bellevue@aopsacademy.org. I'm sure you all have lots of questions for all these fantastic, brilliant individuals joining me here, so I'll pass it back down the line.
Audience questions. And for those of you who are on the stream, let's make sure our microphone, okay, the microphone's still working, great. And the chat, nobody has said anything in the chat. So chat, y'all need to step up and put some messages, put some questions in there, and we'll get to them.
I don't know if it's something on your side, but Matt Cohen's here saying that some people responded to Matt's question with the correct answer of 124.
Whoa, okay. If you gave the right answer, we'll figure out a way to get the swag to you, hopefully. Leave your email in the chat as well so we can contact you. Oh, wow, okay, there's a lot of messages. Okay, we'll need to manage that. But first, anyone in the audience? Yes.
Which math camp would you say prepares best for let's say math Olympiads other than MOP?
Other than MOP, I would not say math camp. Awesome math?
I would say, what kind of So the question was, what sort of camps will provide you with good prep for JMO, AMO, that sort of stuff? I would say beyond MOP, there are a bunch of good entry points with all these college level camps. There's also middle school contest math camp here at AOPS Academy, but also AOPS Online has some really nice products as well. There's a whole bunch of AMY prep courses as well. Back from the MOP.
Okay, so I guess, if you already made MOP, that means you're already really good at Olympiads. Of course, going to MOP will make you much better at Olympiads because you basically just do Olympiads all day for 3 weeks. Well, there's a lot of fun too, but anyways. So, you will definitely improve at Olympiads if you go to some of these other camps, of course, but a lot of them focus on, advanced stuff like sumac, or random stuff like coding theory or quantum whatever, or whatever fractional linear functions are. So if you're looking for like specific contest stuff, I personally I would recommend. I know we don't have anyone here who did Awesome Math recently. Awesome Math, they're kind of just online classes now, which is a little bit sad. But they'll probably get you prepped for contests. And yeah, anyone else want to say anything?
I think HSEM is very like against competitions because it's advocating more for like understanding math like at a deeper level and beyond like competition math. So I think if you're looking to get into math camps, you have to consider like the focus that you want to get into. And for HSEM, it's definitely like they're not going to be teaching you like Olympiad strategies like they would in MOP.
Yeah, one quick thing, Math Camp, again, is definitely not Olympiad focused, so if you are trying to do Olympiads, Math Camp is probably not the place for you. But Math Camp does have some competitions every now and then. Every Wednesday there's something called Team Problem Solving, which is like a team-based Olympiad-style contest. And then there's relays as well, which is competition-oriented. And then they have classes once in a while that are more Olympiad focused, but yeah, the focus is not on Olympiads.
We have some issues with the. Sorry, we're having some technical issues for those of you who are online with the camera. We're going to try to get that sorted out in a moment. But.
More questions from the audience?
Yeah.
Anyone?
I guess for some of the campus like written tests, like what is like some advice you have for both solving like writing up your problem sets, I guess?
I mean, I guess I can say something quickly. I think the most important thing to me was one, like think about it throughout the time that you have. Don't leave it until the last minute, obviously, because then you're going to be like left with a lot of problems at the end. Also, as you're working and as you're making progress, make sure you're like recording all of your thoughts and recording all of your progress as you go, because like you have good thoughts, even if they don't result in something. They're good thoughts to think about, and they might help you to actually solve the problem in the future. And then also, don't be afraid to consult books and like Wikipedia articles and stuff. Obviously, you cannot ask other people directly for help, and you can't post the problems online. But you are allowed. I can't speak for the other camps, but I know for example, Math Camp, you are allowed to consult books for reference, as long as you do reference them in your solution. So don't be afraid to use those.
I would also like to add that something that William touched on was like, think about all the processes that you like. Think about all the process of you thinking about it, and like sometimes like if idea doesn't become fully formed, or maybe you have an extension to the problem, or you're testing the conditions and you solve a problem that's not exactly what they want you to solve. I think it's also a really good idea to put that on your application, because I know especially for like Promise, they want to see you like make conjectures and think about like things open-endedly rather than just like solving a problem. So I would really recommend like thinking about like generalizations or like extending the problem.
Really quickly, just for the online people, the question was, what do you think is the most like beneficial thing or important thing to doing well on the problem sets for these math camps?
Alright, I will add that like Sumac, I think a lot more than the other camps, doesn't really care about your problem set. Like for the problem set, they obviously look at like how well you think, how well you're putting your thought process down. So even if you like don't have an answer, you can say like, oh, this is like how I might do the problem, but like these are the challenges I might have. And then I think again with Sumac, it's really important that your essays do matter. Your essays matter a lot more than a lot of other math camps. Like they ask you like, where do you envision yourself doing in like 5 to 10 years? And like obviously that's not a math question, but like it helps them like kind of figure out who's really passionate about like doing math being here. Like I actually wrote a lot more about engineering and like applying math. So I think like if you look at Sumac, they do talk a lot more about applications and like like sort of crash course everything on the courses that you pick, which is I think pretty different from a lot of other math camps. But yeah.
Any other questions from the audience?
It's two related questions. The first one is, I know high school students are very busy. You guys are passionate about different subjects. So my first question is, what make you choose math camp versus other camps? Because there's so many options, right? You got juggling so many things at the same time. So that's the first question. And second question is, kind of follow up at that question, like the question before is, what's your objective? What do you want to achieve from attending the math camp? Because different objectives will make you make different choices and decisions during the application process.
Yeah, okay. So basically the question was, if I understand correctly, like, it was like, what kind of objectives do you have, like, when you're picking what kind of math camp you want to go to, and also, like, what makes you pick choosing to go to a math summer camp over some other summer camp? Yeah. Who wants to? Anything, Bruce? Yeah.
All right, so I guess I'll answer this because like I applied to a lot of engineering camps last year as well, and like I am by no means a math major. I like went mechanical engineering on all of my college apps, but I think what like why I attended SUMAC in part was because it was Stanford. But then I got there, I looked more into like the curriculum, and I like realized that there's a lot of applications that they talk about. So like I could better apply that to my engineering. Because like honestly, like with a lot of my like high school calc classes as well, our teachers helped us do a lot of labs, and that like helped me realize that like learning math wasn't just like memorize a theorem and take the AMC, but also like it helped you understand a lot of different fields as well. Wait, sorry, what was the second part of the question? Like objectives with learning math? Yeah.
What you get off
Out of the math camp.
Yeah, so I think SUMAC definitely helped me, honestly, like, I wouldn't say enjoy math a lot more, but like it made me realize that there was much more to math than I was like previously assuming. So I guess my objectives in that case would be like being able to apply math and help better understand like the physics or like the robotics that I do or like whatever. But yeah. Anyone wanna take this?
Oh, that's not good. Yeah, so speaking to like, I guess why I went to math camp, basically before math camp, a lot of my mathematical exposure came from competitions. I don't know how true that is for the other panelists here, but I was mainly doing competition math. But I definitely obviously knew that there was math outside of competitions as well. And I clearly wouldn't continue into my life continuing to do competition math after I graduate from high school. And I'd seen some exposure to like advanced college math, and I was really, really interested in it. And looking into it, I saw that these math camps were really, really good places to become first exposed to these like higher level math ideas. So that's one major reason why I applied and went. So if you're looking for a place to, I guess, get exposed to college level math for like a high schooler, these math camps are a really, really good place to do that.
Next question was like, what are good?
Yeah, so I think we're gonna answer a question from chat right now. I think it was what are good summer camps for 8th or 9th graders?
I'll admit that I don't know of too many, especially ones that are in person, just because it's more difficult to host middle schoolers in person than high schoolers. But I am aware that I believe Mathly has a program that's more geared towards middle schoolers. MIT also runs a couple programs, I believe Math Roots or Math Step, which are also more geared towards middle schoolers, and I'm sure other people around here could talk more about some other ones.
Yeah, so Mathly has a program. So basically, when you apply to Mathly, you're applying to Mathly and Mathly. Mathly is essentially like, it's called Mathly earlier. So like, you can kind of guess what that means. It's basically like, they based off the entrance test and like maybe your essays. I don't actually know what they base it on, but they choose people who are earlier in their like mathematical stages for Mathly and yeah. So I think 8th graders and 9th graders, I know there are a lot of 8th graders and 9th graders that are in Mathly yeah, and Mathly is like very similar to Mathly, except that maybe the math is a little bit less like overwhelming. Yeah, it's essentially just Mathly, but slightly earlier.
And at the risk of sounding like a broken record, AOPS Academy does provide lots of great middle school-oriented camps for the summer, as well as AOPS Online.
All right. Any more questions, in-person people?
What kind of sauce or sauce did you use when you prepare for the visit in the camp? Can you recommend some really top sauce?
You mean like classes or?
Yeah, go ahead.
Okay, so to repeat the question, it was asking like what are some helpful if I'm understanding correctly, what are some helpful resources you can use to prepare for the exams or like the entrance tests? I would say that most of the problems that they give you, at least the ones I know for Mathly and Promise, they really aren't trying to test like how much like advanced math you know. They're trying to test like your problem solving abilities, and like so they'll give you like problems which are likely like they use concepts that that any high school can solve without taking some advanced like college level course, but it's really just about your problem solving abilities. So I think that like doing Olympiad problems and doing competition problems, and I know like Math Camp, all the previous year's questions are all there for you to see. So like just test solving those problems, I think can really help you out.
Great. I will remark for the Math Camp quiz, at least the 2022 quiz, there were only 6 problems. There might have been more last year. Okay, yeah, but there were only 6 problems, which is not a lot, so you really have a lot of time to think about them. I think you have like 2 months or something to do all of the problems, so you really get to do your research and learn more about the concepts as you're solving the problems. I will also say knowing programming helped a lot, because for the Math Camp quiz at least, you can use anything you want, literally anything you want, just not other people. So I used computers to get some initial ideas for a lot of the problems, and would recommend knowing programming as an exploratory tool. Yeah, mathematicians do need to know computers. Okay, I think we're coming up on time, but if there's any last questions. Yes.
I'd like to know how much time do you guys spend doing the problem set?
So
Say spend a few days or use up all the time.
Yeah, so the question was, how much time did we spend working on the problems for the quiz or application?
Yeah, the quiz.
Right. I guess we can just go down. For Math Camp, I spent most of break, so it was like 1 week working on the problems for a couple hours every day. I don't know, added up to like 20 or 30 maybe in total.
Yeah, for me, I think I used actually a lot more than that. I was pretty much thinking through. Well, okay, I was doing multiple camp applications, but I was thinking on and off about the Math Camp problem set for pretty much the duration of the 2 months that we had. A lot of the time, I wasn't like actively thinking about the problem set. I was just like maybe in passing. I was just thinking about what could I do for this problem. But yeah, I was thinking about it for 2 months.
Definitely, actually, it was more than 20 to 30.
Like 100.
And now this is the benefit of not going to a math camp. I spent about an hour and a half on the essay and 10 minutes getting my teacher recommendation for a total of about 100 minutes, plus probably 5 minutes for filling out the extra fields on the application.
I think for Promise, I spent a terrible amount of time on it. I think it basically took up my life for like a whole month. Yeah, I spent like a very long time on it, and I also agree with like thinking on and off. Like sometimes like I'm eating lunch and then like, oh my god, number 7 is just so easy now that I think about it. And then yeah, I just thought about like it was just my whole life for a month.
Yeah, so I think this time around I'm gonna spend more time, but the first time I started like a few weeks before the deadline, probably a week before the deadline of HSIM, and because of that, I mainly was taking those weeks like during school, just like during like free time, free periods, thinking about that. And I think HSIM is a lot less like strenuous in that sense because the test itself isn't as hard as like Promise or Math Camp. So it took me like probably 7 hours to finish everything, and then a few more hours to like write it up on LaTeX.
Yeah, so I am an insane procrastinator. I started about 2 weeks before it was due. I finished at 11 p.m. the day it was due. It was due at 11:59. But like, not that it's something I would recommend. Like, I do know people who started it like a week before, and also people who started like 2 months before. So it really varies, and especially with sumac, like the stuff on the test is literally the stuff that like he's gonna be teaching you in class. So like, they by no means expect you to know it or like prepare for it. It's just like how much you want to like spend writing out your thought process and how you would go about approaching the problem.
Okay, well, obviously, there's really no application for MOP, so you just do math contests, I guess. So I actually got rejected from math camp the first time I applied. So roughly the same as William and William, like maybe like 2 to 3 weeks working on the problems, like on and off, just like in free time. So I think we'll wrap up here. Yeah, okay, I'll just wrap it up. Yeah, thanks you guys for coming, guys. Hope you guys learned a lot. And thanks for our online people for showing up, and we'll be done now.
Our website is
Yeah.
community.org. We'll be posting all of our events there. Sign up for our mailing list if you haven't already, and thanks for coming.
Yep, thank you guys for coming.